Hello and welcome back to another episode of Game Dev Security. Today we're going to look at integrating Firebase App Check into our game. Now Firebase App Check is a service which will validate the integrity of your app and also the integrity of the device it's on. What does that mean? Well, basically a lot of hackers will use a cracked version of your app, or they'll try to inject some code into your app to make it easier to crack, or they'll have kind of scripts or bots that play the game. And they'll also do this on emulators, or they'll have to have like a rooted device or a jailbroken device. What Firebase App Check does is it'll basically, if a user is playing on a rooted device or playing on a version of the app which has been changed or tampered with, it will tell you that, and you can reject any gameplay from the device and thus not send those people the sats, etc. So we're going to look at integrating it, but the first thing, obviously, we need to have a Firebase account. So we go to Firebase, add a project, we're calling it FlappySats. Continue, select default account for Firebase, and just wait for this to create the project. Okay, once we've created the project, we'll go into the project. And now we want to enable the app check. So we go to all products and enable app check. Click on how do I get started. So basically you need to set this up for Google Play and Apple. So for Android, we need to do the Play integrity on Android. So we need to go to our Google Play console. And we also need to make sure we have our app created in the Google Play console. So I'm going to make it here. And so Google Play Integrity is Google Play's Android version of the attestation library that will basically check that your app is legitimate and that device is legitimate. So you need to set up Play Integrity here. We need to press link cloud project. We're going to link FlappySats, that's already loading. Now let's have a look at doing the same thing on iOS. We need to set up, so iOS uses something called device check, which is Apple's version of app attestation. So we need to head over to the Apple developer site and create a device check private key. All this is in the documentation on Firebase. I thought I'll just show you how I did it. So I'm on my Apple developer account. I head over to certificates and identify the profiles, and I make a new device check key. I'm just going to call it device check. And I register that. I need to download this file and keep it secure. Now in Firebase, I need to actually set up the apps inside my project. So I'm just going to register the Android app. I'm going to enter the bundle ID or the package name. For me, it's com.zbd.flappysats. Give it a nickname, but this is optional. And to press register app. To download the config file, this will go in the Unity project in the assets folder. And I can ignore this for now. And now I need to set up the iOS app. So I add an iOS app, same bundle ID, register app, and download this config file. This is all pretty standard stuff for adding Firebase to your apps. I can ignore this for now. Now I have the apps registered, I need to set up the apps. I need to wait a while for them to show, apparently. Okay, now I need to do a little bit more setup on these apps. So for Play Integrity, I need to add the SHA-256 certificate fingerprint, which I can find on the Google Play console. So if I go to app signing, I need to create a release first. I'll just create a new release. We only need to release this on internal testing to test this. And I'm going to generate a signing key, use Google generated key. Now if I head over to app signing on the left, there we are. I need to copy the SHA-256 certificate fingerprint here and paste it in the Firebase console. I'm going to set the token time to live to 30 minutes, just makes it a little bit more secure. I'll explain what that means a little bit later. Now I need to do a similar setup for iOS. Add device check, and now I need to upload that device check key I generated. And also change the token time to 30 minutes. Oh, I just also need to add the key ID, so I can find that in my Apple developer account. So the key ID is that, paste that down. My team ID, I can find my team ID in my membership section. And now they are both set up on the Firebase dashboard. So the next steps will be actually adding the Firebase App Check SDK into Unity. So now let's look at adding the Firebase SDK into our Unity project. So first we have to add the config files we downloaded, the Google Services files from Firebase into our assets. Then we want to go to assets, import package, custom package, and download the Firebase appcheck.unity package. So you can find the Firebase Unity SDK on the Firebase website. Just Google Firebase Unity SDK and grab the latest. So let's import this. So I've got everything imported already, but just press import. Now once it's imported, we need to go over to our project script files. So you want to check out the security4 branch on the Git repo. And what we're doing is after the Unity's complaining as usual. Oh, it's just doing some dependency updates. Anyway, so we have this function get app check token, and I'm calling this after the login success. So after on login success from PlayFab, we have this code here, which basically just it's default boilerplate Firebase code. It just checks everything set up right. Once everything is set up right, then we call the app check token function, which is this function here. And basically this will either return an error or an app check token. So basically it'll return an error if the device is not legitimate or the app is not legitimate. And if it's kind of legitimate, but it's not sure, it'll return the token. And with this token, we're going to use that token on our server, which I'll introduce in a little bit, to query the Firebase API to see if the device and app is indeed genuine. So once we've got this token, I'm calling a function here to basically verify the user. Now, we need to talk a little bit about servers at this point. Unfortunately, we can no longer use PlayFab anymore because of the limitations with PlayFab. PlayFab doesn't have the Firebase admin SDK in order to verify the token. It might be possible, but it's just easier to spin up our own server. And also this will open our app up to some other interesting security things we can do, such as Zebedee Shield, which I'll talk about in a future episode. Anyway, I'm making a request to my server. I'm sending the app check token, and I'm also sending the user's PlayFab ID. So PlayFab ID I grab on login as well. Here. So once I've got the token and the PlayFab ID, I'm sending that over to the server. If it's failed, I'm just setting the app check token as error, so I'm sending error across. And now what we're going to do on our server is we're going to do two things. We're going to use this app check token to make a call to the Firebase API, and that will tell us if it thinks the device is legitimate and if the app is legitimate or not. And if it's legitimate, we're going to basically save to our PlayFab backend. We're going to say that this user is verified, and if it's not legitimate, we're going to say they are not verified. And this way, when we do the withdrawal, we'll be able to know if the player is on a real device and a real app, and if not, we can block the withdrawal. So let's look at this server we've written. So the source code for the server will be on Git as well, and I'll link to it in the description. This is called anti-cheat example server. So you can basically just copy and paste this and deploy it on Heroku. I'll put more instructions in the README for this repo on how to do that. But it's basically a Node Express server. I've added some of my play setting information, playfab information here. So it gets the token. We use the Firebase app check API to verify the token. If the token is decoded, if it's okay, then we basically we send verified true to our playfab user. This is why we need the playfab ID. And if it's not verified, i.e. the token is invalid, we do not set the user as verified. So this way, we can basically control the withdrawal of sats on playfab to only verified users. So this is deployed on Heroku. So for those who are new to Heroku, Heroku is just an easy way to deploy apps, such as server apps. So this code for our server, you can basically do a couple of commands and it will be deployed on basically on the web, and your app can access it. It's a lot easier than having to go through, Amazon EC2 or something like that. It just makes it very, very easy. And the server cost is as little as $7. My server costs about $25 a month to run, so very minimal cost. But it's very important to have your own server because, like I said, we can use a Firebase SDK to verify the device. We can also connect to playfab, so we can also use playfab as well. And in a future episode, as I mentioned before, I can show you how you can use Zebedee Shield, which is another security product from Zebedee, and to basically connect to that, you will need your own server. So again, more instructions on how to deploy this in the description. Anyway, so that's basically it. So just to confirm, what happens is after playfab has logged in, we get the playfab ID. We just do some boilerplate Firebase code and we get the app check token. Once we got the app check token, if we get an error, we just set it as error. If we actually get the token, we then make a post request to our server. You will have to change this URL here to your own Heroku URL or your own server URL. Again, more instructions in the README on how to do that. Once you deploy to Heroku, it will basically give you a URL that you can copy and paste here. Anyway, we basically send that across. Our server then verifies the token, and if the token is okay, we know the device and app is verified, and we can save that to playfab. If we go over to our playfab cloud script, I've added some code here. Added some code in the withdrawal. We basically we get the verified from the user internal data. If verified doesn't exist or verified is not equal true, we basically return please contact support. So if we run this in our Unity editor now, we probably get an error because basically play integrity is only supported on an Android platform. So just for now, we're going to focus on Android. I might do a follow-up tutorial on how to do this on iOS. It should work the same, but I'm just demonstrating on Android for now. So now I'm just going to run this on a real device and show if we can see the app check token. As we know, it doesn't work in the editor. I think there are ways around it. You can use debug tokens, I'm not sure, but it's always good to have a real device. So I'm just using this logcat tool so we can see the logs. And if we scroll down, we can see playfab logged in. And yeah, we can see here that device check failed. So it says app attestation failed. So the reason this is failing is because Firebase app check has basically detected that this is not coming from Google Play. This is basically like a debug build. So that's kind of good. So in this case, what would have happened is this would have been sent to our server, and the token would be error. So we'd update the user with verified equals false. So I think if we go to playfab, we might be able to see that verified is false here. Yep, we can see that verified is false. So now when we actually go to withdraw, Oh, if I can actually get one, okay. And I enter my gamer tag. It says please contact support. Because we can see here, if verified, if it's not verified, we'll do please contact support. So I think you can actually, there is a setting in AppCheck to basically add your own testing device. But one way to test it is to actually upload this app to Google Play into our internal testing and download from there. So I'm just going to do that, and we should actually get verified as true, because this is a legitimate version of the app that's coming from Google Play on a legitimate device. So this is me downloading it from the internal test program. This is the quickest way to test on Google Play console. You just upload your app build to the internal test track, and you can download fairly straight away. I find if you actually delete the cache on the Google Play app, the app should show right after uploading it. Now we open it, we should actually get an app token. So we can see app check. So you can see here, yep. So the app check has actually returned this token, and this token would have been sent to our nodejs server, and it should be verified because this is a real device and it's a real app. So if we go over to PlayFab now, title data, I think this would be a different user because it's a slightly different build. It's coming from the Play Store, so it will be a different PlayFab. So, yep, it was this user here. We go to player title, and we can see that verified is true. So now when we go to withdraw, the stats will be withdrawn correctly. So this is a very, very powerful tool. I can't stress how important I think it is to add Firebase app check to your game. We see one of the most common attacks we see on games is hackers will basically kind of crack the app and then install it on 1,000 different emulators and kind of have bots playing the game. So it's very, very hard to fight against. But app check should hopefully stop this. And it's basically free. I think on Android you get a limit of 10,000 checks a day. But if you contact Google, you can get that up to 1 million. I contacted them, and 2 days later they increased my rate limit to 1 million. So this is just for Android for now, but I think iOS should work the same. That's why we use Firebase app check, because it kind of wraps it all. The Unity code should be pretty much the same. There might be a few extra steps you need to do on Xcode or plist, I'm not sure, but you can follow the Firebase documentation for that. Anyway, in the next episode, I want to look at how we can actually add a Zebedee shield to make our game even more secure. What Zebedee shield does is basically it monitors the user on the network level. So if a user is playing from an IP address which is known to be fraudulent, it will ban that, and it'll also limit the amount of sats to each IP address. So if a player is at home playing on 10 different devices, you can detect that and make sure they only get enough sats for one player. But to do that, we need to get their IP address, and PlayFab does not give us the IP address, so that's why we can actually use our new shiny Heroku Node.js server, and we can actually get the IP address and then connect it to Shield. But more on that in a future video. I just wanted to spend a few minutes to talk about caveats with the Firebase app check. There's one issue is you might get false positives. So for example, I have a legitimate player who, for whatever reason, app check is saying they are on a fake device or a fake version of the app. A common cause for this is maybe their device is actually rooted. They just rooted it or jailbroke it for some other reason, but they're not malicious. You trust them, so you want them to play. Another reason could be they just have an Android device from an obscure manufacturer, which Google doesn't recognize. So in that case, they won't be able to play. So it's probably a good idea to add a whitelisting feature. It's very simple to do. In the player data, you basically search for the player you want to whitelist. In internal data, you would add an extra key, whitelisted. You would set it to true. And then in the cloud script, we get the whitelisted value. If it exists and if it's true, we set whitelisted to true. And we only do this check if they're verified, if they're not whitelisted. That would just allow you to manage gracefully. So because we're already returning this, please contact support error, if a player is not passing the app check, they would contact you. You would, make a judgment if they're okay, and then you would whitelist them. That's an important feature to add. Another caveat is, I alluded to this before, with regards to it's probably a good idea to encrypt the app check token when it's sent to the server, using the encryption tools we did with the replay and mirror attack. If you have not seen that video, please check it out. The reason is there is a possible attack here that, say I'm a hacker and actually have my jailbroken device, which I'm going to use to hack the game, and I have another device with the, the actual app on it. I could basically run the app on the legitimate device and use Charles Proxy to see the app check token, then use that token in the request from my jailbroken device, and then the server would most likely set the PlayFab account on that device as legitimate. So I'm basically taking the legitimate token and using it on a illegitimate device. That is a possible attack. I mean, it would require the attacker to actually have a legitimate device, so it adds some cost there. But this can be protected against by encrypting it, because they wouldn't be able to see the app token unless they extract the encryption key and manage to decrypt and steal it that way. So it adds an extra level of protection. Again, as I mentioned before, there's no one silver bullet to stopping cheats. A dedicated attacker will crack everything, but we just want to make it as hard as possible, that it's hard for them to crack this app at scale, and also it's not worth their economic time. Anyway, just wanted to mention those important caveats. One last thing before I go, something that wasn't included in previous builds of Flappy Sats is I noticed that the packaging on Android was set to mono, but make sure you set it to IL2CPP and ARM64. The reason is it just makes it a bit more secure, because IL2CPP kind of does some obfuscation anyway, and it also let it run on more devices. That's a little bit of housekeeping there. Anyway, thank you for watching.